Aloha, everybody. My name is Leilani Funes, and I currently am a senior at the University employee at West Oahu, and I'm majoring in business, specifically business marketing as well as economics. And I'm in the Citrus program that is also part of the Hawaii Data Science Institute. So my project this month was on solar. So this is the Hawaii Solar Project. So why solar? I chose solar because solar is it's a popular source for renewable energy, not just on Hawaii, but in the United States in general. It's fairly clean and fairly inexpensive for renewable energy. And it's pretty widely accessible because it's suitable anywhere sunlight hits the surface. But the big question that I wanted to answer with my data is where is the most optimal place to install solar panels on Oahu specifically? So to get insight on that, we need to first understand how solar is created. So photovoltaic panels, which is also referred to as PV panels, capture solar radiation and they convert it to electrical energy. And the amount of solar radiation will vary based on location because not all spots on the island specifically will get the same amount of solar radiation, which is why I'm trying to figure out the most optimal location to have solar panels. So we did a little bit of data manipulation. So I used Oahu cloud coverage data from 2020 given by Dr. Sadowski from UH Manoa. And the big variables are location and irradiance. So location is latitude, longitude, irradiance is measured in watts per meter squared. So how the data is given, it's given for the whole year of 2020 from 7 a.m. to 7 p.m. in 10-minute intervals. So 7 a.m., 7:10, 7:20, 7:30, all the way from January 1st all the way to December 31st. And this was given to me in an HDF5 file. So I used Google Colab and various CSV files, and I created a CSV file that had the location name of all of the current solar panels on Oahu, as well as their latitude, longitude, and then I inputted that into Colab, into a code in Colab to pull the information from the HDF5 file, which is the bigger file, and it spit out an average irradiance for the year. So for example, for the first one, it's the computer science department. It has a latitude, longitude. They put that points into the code to pull out from the big data set, and the data set basically took the mean of all of those points and spit out a number, and that is the number that we will be comparing. And then we created another CSV file and basically put a box around Oahu just to get every single coordinate around Oahu to get the average irradiance over the whole island. So if I didn't explain already, irradiance is the amount of light that hits the surface. So it's the amount of sunlight that hits the surface. And this is important because this is the amount of sunlight that will be used for the energy for the solar panels. And then with that, we looked at the points we need, which is basically the island. And we created a heat map in Tableau. And the average radiance doesn't start at 425, like that's not the range. It's just an arbitrary number to give a better idea of the picture. And this is for the whole year of 2020. So on the left is the code that we had used. And then it spit out a whole bunch of numbers on a really big CSV file. And plug that into Tableau, and I created the heat map. Now, if you look at the heat map in reference to the solar panels that are already in existence, you can see kind of a pattern. The darker the red color, that means there's more irradiation, which is more sunlight hitting the surface. So that is obviously where we would want solar panels to be built. So you can kind of see the pattern of the irradiation. It goes through the middle, like the central locations of Oahu, and there's a lot on the outskirts of Oahu. But there is some points, so these points on the west side, as you can tell, they don't have a high irradiance. So they're not the most optimal location, but they still give a good amount of irradiance for solar panels. It's just not the most optimal. The most optimal that I did find is the coastal points on the east side, which I'll go into more depth in a few slides. So this is my big Y, potentially optimal locations. So I picked two that were high. So the irradiance is 509 for both, roughly for both points. And then we have two different locations. And just to compare, the highest irradiance from the current locations of solar panels is 503. So this is slightly higher in terms of irradiance. However, I personally don't think they'd be the most optimal, only because they are very, very, very close to water. So there's not much land to build on to create a big enough solar panel to create enough energy to make it worth it. As you can see, they're both very, very close to the edge of the island. So, which is why I personally don't think that they would be optimal. In terms of irradiation, they are optimal, but in terms of like actual location on the map of Oahu, they are not optimal. And this is one point. And then the second point is next to Diamond Head, which is also a very popular tourist destination, which is also why I don't think it would be optimal. It's just too busy. There's just not enough land to give enough to build a big enough solar panel to make it worth building. And then here I just illustrated the difference of irradiation over time. So these are for the two locations I had I showed prior. And as you can see, they're fairly similar. They look almost identical. However, there are differences, but you can see that during the summer months, so from March all the way to roughly October, there's not much difference. There's not much differentiation. It's fairly the same amount of irradiation, but the dips come in the winter months. And that kind of correlates to cloud coverage because there's more cloud coverage over the winter months, especially with how much sunlight we get during those months. So that does make sense that during the months of like November to like late February is why there's not as much irradiation as the summer months. But I just thought it was interesting that majority of the locations of current solar locations look like this map. So I just thought that was pretty interesting as well. And then just some conclusions of my project. Cloud coverage can be used to show which locations are optimal for solar PV, but just keep in mind, we do also have to take in other factors. And then from the data I discovered and the data I cleaned up, east coastal points attract the highest amount of irradiance. And I thought that was interesting, which is why like east side, the east coastal points, it has a lot of irradiance, but if you could tell in the map of where the points of solar panels are, they're not there. They're more on the west side. So I thought that was interesting. So maybe we can build more on the east side. And then there's a pattern where high solar irradiance locations and just locations of where current solar PVs are at, which makes sense. And then I did want to give a quick thank you to my senior mentors and near peers, Dr. Sadowski and Oscar. I really appreciated the help that they gave. And I also wanted to thank Dr. Alex for giving me this opportunity and the Hawaii Data Science Institute for allowing me to learn more about data science and just get a better idea. And thank you so much for listening to my presentation. I'm so sorry I couldn't be there, but I really appreciated working with everybody this month.